Oh, hi there. Let me turn, whoops. Let me turn that off. Okay, you just caught me listening to the radio on this nice summer day. You know, radios, this is a little transistor radio. It's really old, but it's really cool. This is what we used to listen to before cell phones and all that kind of thing. But I tell you what, cell phones, radios, none of this would be possible without math. But I'm going to tell you what, you could invent something that you don't even know exists yet. Everybody who's invented something started where you are, okay? Everybody who's invented something learned their multiplication tables, learned math, went step by step just like you are doing. Nobody started out, you know, like at 2 years old knowing how to do algebra, okay? Everybody learns step by step. So people that developed and invented things, they were doing exactly what you're doing right now. So you were exactly doing what you were supposed to be doing. Okay, I'm going to show you something. We're going to head over to math camp again because that's one of my personal favorites. Okay, I'm going to show you how to solve one-step equations. Okay, now here's the thing. You have been doing this for a long time. You just didn't know it. You've been doing algebra and solving equations for a long time. What you saw, solving one-step equations, you've been doing this for a long time. What you saw was something like this. You might have gotten a worksheet where it said fill in the box. Something plus 5 equals 8. So you had to figure out in your mind, I don't know what grade it would have been, second or third or fourth. You had to figure out in your mind what number plus 5 equals 8. So you were thinking, okay, 5, 6, 7, 8 have to be 3. So you would put a 3 in the box, and that would be right. And mathematicians decided, you know what? Always put in a box for the unknown gets a little cumbersome. We can't always put in a box for the unknown. So they were scratching their heads a little bit and they were thinking and they thought, you know what? We've got 26 letters of the alphabet. Let's just use one of those instead of a box. Okay? They could have used a star. Star plus 5 equals 8. Well, the star would have to be 3. They could have used a smiley face, something plus 5 equals 8. They could have used all kinds of things, but they said, you know what? We've got 26 letters of the alphabet. Let's use those. So that's what they use. They use X, they use A, they use Q, they use X, they use R. They don't use O a lot because O can look like a 0. So they don't even like to use cursive O that often because that looks like a 0, like I said. Let's see, they don't use like L, like, you know, you have a capital L and a lowercase l. They don't really use L like that because it looks like a 1. They might use a cursive L. Okay, so anyway, let's see how using letters is the same as a box. So here we have X, which is some number, like a box, plus 5 equals 8. Well, what plus 5 equals 8? Well, again, it'd have to be 3. Now here's an algebraic way to untangle this. If I subtract 5 from both sides of the equal sign, so this is like a scale. This side has to equal this side. 3 plus 5 equals 8. Over here you have 8, so you have it equal on both sides. This has to equal 8. So what I can do is I have 5 here, I can subtract 5 from both sides. So on this side, a positive 5 minus a 5, well, that goes away. So I just have X. Here I have 8 minus 5, and I have 3. So algebraically, it looks like this, X equals 3, which is the same as saying, hey, box equals 3. Okay? So let's use that idea on a few more. Here I have some number A plus 2 equals negative 7. Okay, I look where my variable is right here, and I want to get that by itself. Here I have a positive 2. So think of a scale. I have 2 here. Well, I'm going to take away 2 from each side to keep the scale equal. So I'm going to take away 2 here and take away 2 here. So a positive 2 and a negative 2 is 0. That goes away. So I just have A equals. Now a negative 7 plus a negative 2, or in other words, I have negative 7 minus 2, which we know is negative 7 You can change that to plus negative 2. That's going to give us negative 9. So you end up with negative 9. Okay, now I didn't show the actual written check right here. Let's show the written check. If I put in negative 9 for A, like if I put in negative 9 for the box, negative 9 plus 2, does that equal negative 7? So here off to the side, I'm just doing a check. Negative 9 plus 2 is negative 7, and that does equal negative 7. So that checks out. Okay, over here, sometimes they put the variable on the right-hand side. Here, q is on the right side of the equal sign. Well, that's okay. We want to get q by itself. I see that it's joined with a negative 5. Well, I want to do the opposite of that. That's a negative 5, so I want to add 5 to both sides. So over here, negative 5 plus 5 is 0, so I'm just left with q. 12 plus 5 is 17. So that would be my answer for q. Okay, again, you could check it out. Let's put in 17 for q. Does 12 equal negative 5 plus what I just got for q, 17? And it does. 12 equals negative 5 plus 17 would be 12, and it checks out. Okay, over here. Here I have negative 6 equals x minus 10. Okay, I look at where the variable is. Is the variable on the left side of the equal sign or the right side of the equal sign? Okay, you're right. It's on the right side of the equal sign. So I have x minus 10. I need to get rid of this minus 10. So what I'm going to do is add 10. I'm going to do the opposite of that. I'm going to add 10 to both sides. So over here, negative 10 plus 10 is 0. That goes away. So I just have x. Over here, I have negative 6 plus 10. Well, that's going to give me 4. So my answer for that would be 4. Now this is the first one where we had a minus sign between the variable and the number. Here we had a plus, here we had a plus, here we had a plus. Let me show you another way to think of this. I'm going to use a different color marker so it stands out. Okay, we had negative 6 equals x minus 10. Well, remember that a minus is the same thing as negative 6 equals, I could make that plus negative 10. Okay, now you can see that's a negative 10, so I need to add 10 to both sides. Negative 6 plus 10 would give me 4. Here, the negative 10 and the positive 10 are 0, so I just end up with x right here. So here I do get x equals 4, which is what I got over here. I just didn't show that step where I changed it to adding the opposite. I just kept it as a minus 10, and then I just added 10 to both sides. Okay, now that's different than this problem. This is negative 6 equals x plus 10. So here I have a positive 10. To solve for x, to isolate x, to get x by itself, I need to do the opposite of this, so I need to subtract 10. So a positive 10 and a negative 10 are 0, so that just leaves me x over here. Here, negative 6 minus 10, well, that's going to be a negative 16. So that would be my answer for number 5. Okay, and again, I'll show the check. Does negative 6 equal, I just found x to be negative 16, so I'm putting in negative 16 for x. Does it equal negative 16 plus 10? Well, let's check it out. Negative 6. Here I have negative 16 plus 10. Yep, that's negative 6, so that checks out. That's what I love about math. You can always check your work and see if you have the right answer. Okay, let's do one more. Here, look for the variable. Is the variable on the left side of the equal sign or on the right? Okay, it's on the left side, so I need to get this variable by itself. So I look at the number that it's with. Here it's with a negative 9. Now think to yourself, what should I do to get r by itself? I want to get rid of the negative 9. What should I do to both sides? Should I do plus 9 or minus 9? You're right, I should plus 9. Negative 9 plus 9 is 0, so I just get r equals 5 plus 9, well, 9, 10, 11, 12, 13, 14. Okay, so that's 14. So r equals 14. And again, we could check it out. Negative 9 plus 14, does that equal 5? I'm looking back at the original problem and plugging in 14. Well, negative 9 plus 14, okay, I have a positive and a negative, so 14 minus 9 is 5. I'm going to take the sign of the larger one, so 5 equals 5, and it checks out. Okay, that is it. I just wanted to show you, and I'm going to have you practice some of these on Delta Math, but let me show you what it looks like first. Okay, here I have it pulled up. It's called One-Step Equations Type 1. Here I have negative 6 equals s plus 6. So what I would want to do is subtract 6 from both sides. So my answer would be negative 12. Let me type that in. Where's the negative? There it is, negative 12. Submit answer. Is that what I want to submit? Yes. And we got a check mark, we got it right. And here they show you how you work it out. So it says subtract 6 from both sides, and you get negative 12. And our answer was negative 12, so it was the same thing, it was correct. Okay, let me show you one more. New problem. Oh, let's do a different one. There we go. Oh, that's wow, okay. How about this one? Okay, here, if you're all of a sudden you're shaking your head like, what do I do? You could always hit show solution. It shows you how to work it out, and then you can refresh your memory. Oh yeah, I need to solve for c, so I need to, that's a minus 3, so I need to add 3 to both sides. So you get c over here on the right, and over here, negative 4 plus 3, you get negative 1. So don't be afraid to do that if you're working on something, because you're learning right now, okay? So if you get a little frustrated, or not even frustrated, but just kind of like, what do I do there? Hit show solution, and then do a new problem, but go hit show question, and let's try this new problem. Here's the t. Think about what you want to do. You want to add 1 to both sides. So negative 6 plus 1 would give us negative 5. So I'm going to put in negative 5, and I'm just going to hit enter. Do I want to enter that? Yes, I do. Yay, green check mark, we got it right. Okay, so give that a shot. You guys are going to be so ready for all the math that you're going to do in your life, and you are going to invent something new, like a transistor radio. Okay, I am just sure of it. You guys are doing great, and okay, we'll talk to you later. Bye-bye.